2013. Marine researcher Andrew Sweetman from the Scottish Association for Marine Science carried out his research in one of the most remote and mysterious regions of the Pacific, Clarion-Clipperton Zone. Spanning the distance between Hawaii and Mexico, this massive stretch of seafloor is nothing short of staggering. It's much larger than India. Sweetman's team deployed instruments to measure oxygen levels near the seafloor, expecting the usual pattern, oxygen slowly declining as microorganisms consumed it in the darkness. But beneath 5,000 meters deep in the ocean, something extraordinary appeared in their readings. Oxygen levels weren't falling, quite the contrary. They were rising. How could it be? In a place with no sunlight, no photosynthesis, and no known source of oxygen, there must be something wrong. And so, they dismissed the readings. Something had to be off. A glitch, perhaps a technical malfunction. After all, every study before this had shown oxygen vanishing in these depths, not mysteriously appearing. They filed the data away and moved on. But deep inside, the mystery lingered on Sweetman's mind. It took almost 8 years before he was able to revisit this mystery. In 2021, Sweetman returned to this part of the world, this time with different tools, new methods, and fresh eyes. And once again, the ocean answered with the unexplainable. Oxygen, fresh, unmistakable, was appearing in the pitch-black heart of the deep, defying everything science thought it knew. This naturally created a buzz in the scientific world. This phenomenon was later termed as dark oxygen, a fitting name since it defies the notion that light is needed to produce oxygen. Calling this discovery one of the most significant in recent history wouldn't be an exaggeration. These findings could shake the very foundations of biology, evolution, and even the origins of life itself. To understand why this is so earth-shattering, we'll need to get back to our Biology 101. The vast majority of our oxygen comes from photosynthesis, the process by which plants, algae, and some bacteria capture sunlight and turn carbon dioxide and water into sugar and oxygen. This oxygen either enters the atmosphere or dissolves into the upper layers of the ocean, supporting marine life. But light doesn't reach more than 200 meters below the surface. Beyond that lies eternal night. No known oxygen production. Hence, the discovery of Sweetman revealed something we haven't known previously. Something in the deep is breathing life into the darkness. What is it? At first, researchers tried to explain this through the ancient process called thermohaline circulation. This is a global conveyor belt driven by temperature and salt. Cold, oxygen-rich waters from the polar regions sink and begin a sluggish journey along the ocean floor, creeping across the globe over centuries, sometimes for thousands of years. This flow delivers a vital, though limited, breath of life to the deep sea. Without it, much of the ocean's abyss would be an oxygen-starved desert. But what Sweetman and his team uncovered in the Clarion-Clipperton Zone didn't play by these rules. The oxygen levels weren't just being preserved, they were rising. It became evident that something else was happening. Then, almost unbelievably, the answer revealed itself on the seabed. Literally, the polymetallic nodules. These peculiar metallic rocks that are lying scattered across the seafloor thousands of meters below the surface. At first glance, these nodules appear to be just ordinary rocks, but beneath the surface, they are anything but. Over millions of years, they've developed layer by layer as metals like cobalt, nickel, and manganese gradually accumulate around tiny fragments of shell or bone. These ancient rock formations had always been coveted for their metal wealth, but Sweetman couldn't shake the feeling that they held a deeper secret. He followed that hunch, and he was right. In the end, their true worth turned out to be far greater than anyone had ever expected. Scientists found that these nodules are creating small electrical currents, which may be triggering a process known as electrolysis, breaking water molecules apart into hydrogen, and most importantly, oxygen. To put it simply, the ocean's floor may be wired for oxygen. If proven true, it would mean these nodules are producing oxygen without sunlight, without life, and without precedent in the natural world. To test their idea, the team recreated the deep-sea environment in a shipboard lab. They sterilized samples of the nodules and the surrounding sediments, removing any trace of biological life that could account for the oxygen. Then they sealed everything in airtight containers and watched. Sure enough, just like on the ocean floor, the oxygen levels inside the sealed environments began to climb. To top it up, they found that the nodules were generating a measurable electric current, up to 0.95 volts. To put that into perspective, it takes about 1.5 volts to split seawater through electrolysis. That's the same amount of energy a standard AA battery produces. And so, the discovery was dubbed the geo-battery hypothesis. This discovery shakes the very foundations of how we understand the emergence of life on Earth. For centuries, the prevailing theory has been that oxygen, and by extension complex life, came about through photosynthetic organisms around 2.7 billion years ago. But if rocks can produce oxygen without any biological assistance, we may need to rethink this entire origin story. Beyond this, its impact towards our future can't be understated. Naturally, deep-sea miners would salivate with the idea of exhausting these resources. For years, they've seen them as a jackpot of rare metals, which are the lifeblood of lithium-ion batteries. These tiny powerhouses fuel everything from your phone and laptop to e-cigarettes, military tech, and perhaps most importantly, the electric cars steering us toward a greener future. Cobalt alone can fetch over $30,000 per ton on the global market, while nickel, though slightly less lucrative, still commands a hefty price at nearly half that. Now, with the revelation that these nodules themselves act as natural batteries, they've become even more irresistible. In fact, analysts estimate that the value of the metals in the Clarion-Clipperton zone could be a staggering $30 trillion. That figure is almost beyond comprehension. And for corporations racing to secure the raw materials fueling the green energy revolution, the deep ocean has become the next great frontier. With numbers like that, it's tempting to think companies could simply deploy their equipment and start reaping the ocean's hidden wealth. But extracting these deep-sea riches might not be as straightforward or as harmless as it appears. That seemingly endless treasure of metals could come with a hidden cost. If these nodules are not only generating oxygen, but also supporting fragile underwater ecosystems or contributing to the planet's broader oxygen supply, their role is far more critical than we've ever imagined. Disrupting them could trigger a ripple effect of consequences we aren't prepared to deal with. The implications extend far beyond the ocean floor. This discovery redefines how we search for life across the universe. For years, scientists have relied on oxygen as a key indicator of life on distant exoplanets. But if oxygen can form without biological involvement, through natural electrochemical reactions deep in alien oceans, then what we once considered a telltale sign of life may actually be something entirely different. What if this strange phenomenon isn't exclusive to Earth? What if in distant worlds, similar processes are happening, quietly generating oxygen, quietly sustaining life? Above all, this discovery would have a lasting impact in our society. The very idea that natural processes deep within the ocean can produce oxygen and generate energy without sunlight opens up a world of possibilities. Could these processes inspire groundbreaking technologies? One that could mimic this nature's hidden chemistry to generate sustainable energy. The concept of harnessing electrochemical reactions in the same way these nodules do could lead to the development of new, eco-friendly energy sources. By tapping into nature's blueprint for energy creation, we might find solutions that are not only environmentally friendly, but also efficient and scalable. In the end, we must ask this important question. Should companies collect these valuable nodules to support future industries? Or should we leave them where they are, doing their quiet, crucial work beneath the sea? But what are your thoughts about this dark oxygen? YouTube thinks you'll love this next video. See you on the next one.